Hello, everyone. This is Joe and Ann from MecSoft Corporation. Thanks for taking the time to join our latest edition of our AMS monthly AMS webinar series. Today's webinar is titled 3+2 Machining of Multi-Sided Parts. My name is Joe Anand. I'm the product manager here at MecSoft Corporation. I will be doing a high-level introduction of this webinar. And I'll be joined today by Uday Honalegare, our support manager, who many of you might have interacted with already, and he'll be doing the in-depth demo today. Before we get started, just a few housekeeping tips. The recording, as usual, will be made available to everybody. We'll take about a day to clean it up, and we will send it out to all the registrants. And then we'd like to keep this webinar very interactive, but at the same time, to keep the flow going, we'll reserve the last 10 minutes for questions. But we do appreciate you typing your questions in the chat window where the red arrow is pointing. You can, during the webinar, I will be listening to looking at the chat window, so any questions that come up, we can either respond right away, or we'll stop Uday and have him show some feature that you have questions about. So today's webinar, as I mentioned, is 3+2 Machining of Multi-Sided Parts. We're going to be focusing on what exactly is 3+2 machining and how do you accomplish that in our CAM system. So we're going to start with the 3+2 machining explained. Many of you might not even know where the terminology is coming from, and that's actually an interesting concept with the name itself. And then we're going to talk a little bit about coordinate systems in CAM in general, not just in our CAM system, but in machining in general. And then also we will go into how we handle these coordinate systems using setups in CAM. And then Uday is going to run through double-sided parts machining using setups, using coordinate systems, and then also general multi-sided parts machining. And then finally, talk a little bit about post-processor considerations, what we need to really look for when we are talking about or when you're implementing 3+2 machining in the post-processors. So there, next slide, please. Yeah, okay. So what is 3+2 machining? The 3+2 machining is sometimes also known as index 5-axis machining. This is the ability to machine a part in 3-axis mode. So we are talking only 3-axis mode here. That's why the 3 in the 3+2 machining, the name, the 3+2 machining, the 3 stands for the 3-axis mode from multiple orientations. So you're taking the part and either orienting the part or you're orienting the head of your machine tool in different orientations, but machining in 3-axis mode. These multiple orientations are arrived by rotating the tool or the part, in your case, using the two rotational axes on your machine. That's the +2 part in the name. So maybe that makes a little bit more sense when you hear 3+2 machining. An example part, we have shown a picture of an example part here that does require 3+2 machining because you have features on all sides of the part, or at least 4 or 5 sides of the part. So you will have to come in and machine from different orientations. So there, if you want to go to the next slide, please. Okay, a little bit about coordinate systems in CAM. Most people, when you get a machine tool, you will know that your machine tool has a machine coordinate system. All the manufacturers of the machine, we'll talk about the machine coordinate system, which is basically oriented or centered. The origin of that machine coordinate system is considered the 0 of the machine. And then you will have the X direction typically along the bed, and then a Y-axis that goes into the plane of the bed, and then Z-axis would typically be pointing straight up. This is a very common situation in machine tools. And this is how most machine manufacturers will create a machine tool coordinate system. And we can actually define that in our system. If you have a different machine tool coordinate system in relation to the world coordinate system or the design coordinate system and the part that you've used for designing, we have the ability to change that machine coordinate system. But for all practical purposes, you can think of the machine coordinate system as the world coordinate system when it comes to machining. And then we also have the concept of program or machining coordinate system. you got to differentiate that from the machine coordinate system. We call that the machining or the program coordinate system. This is where you can actually move the coordinate system about which all of the toolpaths are going to be interpreted as. So, I mean, if you, in other words, you can think of it as simple G54, G55, which is only an origin shift, but we also have the ability to actually change the orientation of the coordinate systems and set up something called the program coordinate system, about which all toolpath motions and angles, if you're doing 5-axis, will be interpreted. So these are the two concepts you have to, get straight in your head when you talk about, or when you start looking at 3+2 machining. So without any further ado, I'll let Uday jump into the demo and start with setups, how we actually implement coordinate systems in our CAM system using setups, and then he will jump into two-sided part machining and also multi-sided parts. So take it away, Uday.
Thank you, Joe. Hello, everyone. Good morning, good afternoon, or good evening to you folks, and thank you again for joining us for this AMS webinar series for the month of August. Today, we will be covering, 3+2 machining of multi-sided parts, and as Joe talked about earlier in the webinar today, we will first start by how we can create multiple setups in our CAM system, and this is available in all our CAM products in the mill module. If you're running Visual CAD CAM or our plugin for Rhino, which is Rhino CAM, Visual CAM for SolidWorks, as well as our Libre CAM product lines. So without any further delay, I'm going to go ahead and jump right into our standalone product first, and then we'll take a look at how we can create setups. So a setup basically defines an orientation or the direction from which you would like to machine features in a part. On this particular part, the example that you're looking at here, you have features in different orientations. So you have a feature that you would need to the slot that you would need to machine from the top, and then you have a feature that's at an inclined plane in here. You have a pocket, and you have some holes, and also you have a pocket on the right side in here. So to machine these features, you would need to orient your coordinate system in here. So the coordinate system, as you can see, is currently over here at the lower left corner of the part. So we actually display two triads in here. One of them is the world coordinate system, which is the coordinate system origin in the host CAD system. So in Visual CAD, we display the triad with the coordinate labels on it with the X, Y, Z, mark for the X-axis, Y, and Z-axis. This is your world coordinate system. And then you also have your machining coordinate system in here. So in this particular case, the world coordinate system and the machine coordinate system are coincident, and they're right on top of one another, and they're in the same orientation. So that's the default setting both in Visual CAD CAM as well as in Rhino CAM and in all our other products, which could be Visual CAM for SolidWorks as well as Libre CAM as well. So by default, if you take a look at the part looking down from the top view in your host CAD system, that represents your X-axis, which goes from left to right. The Y goes from front to back, and Z is pointing towards you, as you can see the coordinate system in here. So as I mentioned, the default setup is oriented along the world coordinate system for your machine tool coordinate system as well. Now, with this particular orientation, you will be able to program features that are in, looking down through the Z-axis of the coordinate system. Now, to program from additional orientations or additional sides, you would have to go over to Setup, and you would have to select a coordinate system setup to be able to add an additional setup. So that will allow you to orient the coordinate system to program or machine it from a different orientation. So when you select setup, this displays the orient setup dialog in here, and you have different ways how you can align the coordinate system. One of the techniques that you can use is by using a geometry selection. So you can pick a surface, you can use select surface, and you can just pick a face on the model, and you'll now notice that it automatically orients your coordinate system for machining normal to the surface. So the surface normals could be pointing either towards you or away from you. So if the normal directions are reversed, you can also use these additional controls in here, like the spin angles in here, to orient or to flip it over by 180 degrees. So I'm going to choose, in this particular case, I'm selecting a surface. I just pick this face, and then when I select OK in here, you will notice that it adds a new setup in here. So setup number 2, it orients the coordinate system normal to this face. Just to make it easier, I'm going to toggle off the display of the world coordinate system over here. So I'm going to go into the toolbar heads-up display right across the top and toggle off the display of the world coordinate system. So you'll now notice that the machining coordinate system is oriented normal to this particular face. So you can create additional setups, and the ability to create additional setups are available to you in our Pro and Premium configurations of all our mill modules. So you can create multiple setups. So we've defined the default setup in here, which is normal to the XY plane of the world coordinate system. We've added a new setup, which is basically oriented normal to this particular face. So you can see that the Z-axis is normal to this face. Now this would allow you to program machining operations under the setup, and the tool would be normal to the face that you selected. Now to program one of the additional faces in here, I can go back and create a new setup, and now again I can reset it back to the world coordinate system, and I can use either select a surface, I can pick a planar curve or a planar sketch. I could even set it to be normal to an active construction plane, or if it's a combination of different rotations of like a 90 degree, I can use these controls in here and say I want to rotate about the Y coordinate axis by 90 degrees, and you will now notice that it sets the Z axis normal to this face, since this is a 90 degree orientation from the world coordinate system. You can also go back and edit the setup and change the orientation of the X and the Y coordinates. So I can use these controls in here to rotate it about the Z-axis. So I can have the X-axis pointing along this edge, and the Y-axis and the Z is normal to this. So you can create multiple setups for each orientation. So once you establish this setup, you will be able to program machining operations under each setup. Now, if the machine tool that you are using is just a 3-axis machine tool, you would actually have to go ahead and refixture the part on your CNC machine for each of these orientations to be able to program the part. So once you establish the setup, you can also go ahead and establish your work 0. So if you need to place the origin at a specific location, we can go ahead and add a work 0 in here. So I'm going to go ahead and create my stock, and I can establish my work 0, and the work 0 will basically translate the origin in the same orientation as the setup orientation that you've defined in here. So I could choose set to stock, high as Z, and northwest. So we now have the orientation in here set to stock, high as Z, northwest corner, and you'll notice that your XYZ origin or your work coordinate offset is established right over here for the setup. So the initial orientation, the coordinate system origin is over where the origin is, and then we've added a work 0 to translate the origin to the northwest corner and top of the material. Now for the setup number 2, you will notice that it's tilted in here, the coordinate system, because it's normal to this face. Now if you want to establish an origin, so once you have reoriented the part and fixed it on your machine, you can establish the origin to a location that is feasible for you. You can either use set to stock, set to part, or you can even use the pick option in here, and I can go ahead and use the object snap tools, and I could say I want to place the origin at one of these corners in here. So I can just go ahead and snap to an endpoint, and you'll now notice that the XYZ origin is set to this upper left corner of the inclined plane. So when you orient the part and fixture it on your machine, you would need to establish your work coordinate offset, which could be a G54 or G55 right at this location, and all your tool paths would be interpreted based off these coordinate origin location. Now similarly for setup number 3, where we have the coordinate system oriented to this right side face, if you'd like to insert a work 0, you can do the same step. You can pick set to stock, I'm going to pick the southwest corner in here, high SZ and southwest. So you'll now notice that the coordinate system origin is established over here. So as you reorient the part on your machine tool and you'd be machining it, the machine tool will be looking down from the top in this particular orientation, and the origin is set over here. So this is how you would create multiple setups if you're programming it on a 3-axis machine tool where you need to refixture the part, reorient the part for programming in each and every orientation. Folks, if you do have any questions at this point, please feel free to post those questions and we'll try to get those answered for you. Okay, great. So once you have the coordinate systems established in here, the workflow of programming your machining operations is very similar. So you would just basically go into each setup and program your toolpaths. In this case, you could do a combination of 2-axis and 3-axis toolpaths in here. So 3 plus 2 basically refers to, the 2-axis refers to locking the coordinate system to a given plane or given orientation, and then you can program 2 and 3-axis machining operations. So that's where the 3 plus 2 terminology comes from. So we could program pocket operations for setup number 1. We could do some drilling and hole machining and pocketing operations under setup 2. Then we could also program pocketing and facing additional operations for each of the setup. Now, consider that this is going to be a 5-axis machine tool as opposed to be a 3-axis. So you would not have to go ahead and reorient the part physically, manually. Defining the machine tool as 5-axis would automatically compute the angles for each and every orientation, whether based on the type of the machine tool you're working with. So if you go into the machine tool setup dialog on the program tab, you can set the number of axes from 3 to 5, and now over here you can establish your configuration. So there's 3 possible configurations for 5-axis machine tools that we support. One of them is a head-head configuration where your part remains stationary on the bed of the machine, and the tool would be able to orient to different positions to be able to machine the part. That would be a head-head configuration. Or it could be a combination of a rotary table and a head, or it could be like a trunnion type of machine tool where you have 2 rotational tables where the part rotates and the tool remains normal to your XY plane. So you could be, this could be a good example for a table machine tool. So I'm going to set the configuration as table, and then this would allow you to establish your primary and the secondary axis.
Let me interrupt for a minute. There's a few questions people are asking about the 3 plus 2 module, and if you don't have the 3 plus 2 module, how are we going to machine a part like this? So if you touch upon that briefly about creating multiple part files with different orientations,
Sure.
that'll be good. And then also when you jump into your two-sided machining, there was a question regarding rotate table setup, so maybe you can also show that as well. So.
Sure, we'll certainly do.
Thank you.
Thank you. So over here, we're just defining this as a 5-axis machine tool, so we can establish the primary axis. I'm going to just pick the X-axis. That would be the primary rotary axis, and then the secondary could be a Z-axis. That's typically the case on a trunnion type of machine. It could be the primary could be rotating about X or Y, and then the secondary could be a Z-axis. So we'll specify these in here, and then we'll accept it. So once you define the machine tool as 5-axis, and let me go ahead and just add a couple of operations in here. So I'm just going to do a pocket operation. I'll just pick a face, a flat area, just pick the flow right in here. I'm just going to go select a curve edge region in here for this feature to be machined. We'll grab a tool for it, and we'll specify a depth in here. Generate it. So we have a pocket operation programmed over here. I'll just apply a tool path over here as well. I'm just going to copy this pocket operation, paste it down here, and you'll notice that when we program these tool paths, your clearance is automatically, the clearance plane is oriented parallel to the rotated orientation of your coordinate system in here, so you don't have to worry about all of that. So let's just go ahead and select the control geometry for here. So I'm just going to go ahead and program 2 of these setups, and we'll show you how the system will automatically be able to establish the orientation of the angles for each of these in here. Quickly we'll go through that, and then we'll talk about how we can orient the part when you do not have the 3+2 module for programming parts like these. Okay, so I'm going to generate the toolpath in here, so I could do a similar process for programming this pocket. So we have these 2 setups created in here, and then once you have the machine tool defined, you can select the 2 setups or the entire machining job. You right-click and do a post all, and then you need to select the post that's configured or set up for 5-axis. Then when you hit post, the system will automatically compute the orientations. You can see that the angles are being output as B, 0, C0, so the secondary axis and the primary are 0 when you're machining looking down from the top. And then as you programming the setup number 2, which is the inclined plane, you'll see that the B axis is at minus 45 degrees and the C is at 0 degrees. So if you're outputting as a 5-axis, the system will automatically establish these orientations, the angles, and you can output either in the rotated coordinates or you can output in the world coordinate system. Okay, so now let's look at how we would be able to program this part if we did not have the ability to define multiple setups in here. So I'm going to go back and reopen this part again. Okay, so we've now loaded the part back. So as you're looking down from the top, you will be able to machine features that are visible to you looking down through the z-axis in here. So that would be, you'd program these features in here and save this as part number 1. And in the next step, you would want to program the inclined face in here. So you would have to reorient the part or rotate the part in the host CAD system. In this case, in Visual CAD CAM and Rhino CAM, you can rotate the part. If you're running Visual CAM for SOLIDWORKS or a Libre CAM, we'll show you how we can orient the machine tool coordinate system to be able to machine from those orientations. So in Visual CAM and Rhino CAM, you can orient the part so that the face that you would like to machine is parallel to the XY plane of the world coordinate system. So there are several different ways how we can do it. One of the easier techniques I would like to go over is by going over to this tab called Modeling Aid, and then I can establish or set my C-plane. I can orient it by 3 points. I'm going to use 3 points in here, and I'll use the end object snaps, and I'll pick the origin point, my x-axis vector right in here, and then establish the y-axis vector. So you'll now notice that the C-plane is parallel to that particular face. So once you have established the C-plane to be parallel to this face, I could right-click and choose Align to C-plane. So the view will be aligned to C-plane. So you're looking through, looking through the plane, and you can see that this face is parallel to the view. Once you establish this, you can just go ahead and select all of your geometries in here, go over to Transform, and then you select Part Orient under the Transform menu, and you can say Set as Current View Direction, and this will automatically rotate the part to orient it for you. So now if I go back to the modeling aids tab and set the coordinate system to the world coordinate system, you will now notice that the part is automatically rotated, and this particular feature is now parallel to the XY plane. So you would be able to rotate the part in the CAD system. So you can either use the transformation tools that are available to you in your CAD system, or you could use the setup and the orient part feature to orient the part. So when you have inclined planes, if you're not sure about what the angle is to rotate about, you can use the C-plane by 3 points, and then you do right-click and do Align to C-plane, and then orient to the current view. Now let's go back in here and take a look at how we can orient it using the Orient part feature in here. So go over to the Program tab, you can select Setup, select the Orient part feature. In this particular case, we want to orient it, the part so that this particular pocket feature is visible looking through the top, you can select the direction in here. So you can just pick the directional arrow, and you'll notice that it automatically orients the coordinate system Z to be normal to this face, and when you accept it, it'll reorient the part for you. So there are several different techniques that you can use to orient the part, and you can now save this out as part side 1, part 1 side 2, part 1 side 3, and program each of these orientations as a separate, in separate files, and then post them out to your CNC machine tool. I hope this was able to answer your question. Okay, so now let's go over and take a look at how we can machine multi-sided parts in our CAM product. So for this, I'm going to go over to our Rhino CAM plugin. So plugin for Rhinoceros. So what I have here is a part that would require machining from at least 2 different orientations. So if you take a look at this particular part in here, it's a model of a spoon, and you can see that there are features that cannot be machined just from one orientation. So you have like undercuts areas that cannot be machined by just looking down through one of the orientations in here. So we would need to machine this part from at least 2 sides to be able to program it completely. So we've already created some supports, and we've also created a extent so that the part can be held and in a frame, and then we have supports that are modeled to it. So once you have the part designed and loaded in your CAD system in here, we want to orient it. So we go into setup. I can select orient the part, and in this particular case I'm going to choose to set the Z-axis to be normal to this particular face in here. So I'm going to use I'm going to pick the arrow that's pointing to the face direction, and then pick OK to accept it. So you'll notice that this automatically orients your part, and in the next step you can establish the origin. You could use align, set world coordinates, set to part. You can put it at the center in the Z, center in X and Y. So this will automatically transform your part and the stock from where the location it is to the world coordinate system origin. So in just 2 steps, you're able to orient the part and place the XYZ origin. So once you've established this, you can go through the process of programming the part. So you can establish your stock material. So I'm going to just use copy model bounding box in here to define it, and then I'm going to define the type of machining process. If this is going to be programmed on a 3-axis machine tool, you just leave the machine tool as 3-axis. If you have a rotary table, like a 4th axis, then you can change the number of axes to 4, and you can specify your rotational axis. If your rotary axis is oriented about the X or about the Y, you can establish this right in here. Now first, let's take a look at how we can program this in a 3-axis setup, and then we'll take a look at the rotate table setup as well, as one of our attendees has questions about how to create rotate table setups. So we oriented the part, we've created the stock, so the default setup is oriented in the same orientation as the world coordinate system orientation. So now we can program your machining operations in here looking down through this view. So I actually have a few toolpaths programmed on this part. So I'm just going to go ahead and load that part in here, which includes the toolpaths in here, and then we'll take a look at how we can apply it with the rotate table setup. So what I have here is setup number 1, and I've established the work 0 to be set to the top of the stock material and the upper left corner, which is the southwest corner, and we programmed a roughing and then a drilling operation for these registration holes. So when you flip them over, you can align them, line them up perfectly to the registration hole, so there wouldn't be any offset or shift when you flip the part over as you're programming it from 2 sides by manually flipping the part over. And I also have a finishing operation for side number 1. So let's go ahead and run a quick verification for that. So I'm going to select the play in the simulate tab and run the verification in here. So I'm going to pause it and run to the end. So there's the simulation of the roughing process. We have the drilling operation in here, and then finally the finishing operation for side number 1. I'm just going to pause and let it run through the end on the simulation. So once you have the side program, you would actually flip the part over on the machine tool to program it from the bottom side of the part. So on a 3-axis setup, you basically manually flip the part over on the machine tool, and like we talked about in the previous example, we would create a coordinate system setup to rotate the coordinate system to orient it towards the bottom face. So we have a setup 2 which is now rotated, as you can see right there, and it's pointing towards the bottom face. Now one of the things you would want to note here is when you add a new setup and rotate it, it'll always rotate it based off the location of the coordinate system origin. So you can then add a work 0 to translate the origin to the location where you need the origin to be placed. So in this case, I'm going to share the same edge. So when I did the top, I used the edge over here at the southwest corner. So when I flip it over, I want to use the same edge to maintain. So when you flip the part over and machine it, if you maintain the same edge, you won't run into any offsets. The part will remain square. So I'm going to use the same edge in here. So I'm using the northwest corner to establish the origin, and now we have a roughing operation and finishing operations programmed right in here. So you would basically reorient the part on your machine tool, and then you would be able to run your machining operations for roughing, finishing, and final finishing operations. Now one of the benefits with this 3+2 module and being able to create the multiple setups is you can also run the simulation for all the different orientations, and you'll be able to see what the finished result of the part would be. So if you're saving each orientation and programming it separately in separate files, the simulation, you wouldn't be able to look at the simulation from each of the orientations within the same file. So with the ability to create multiple setups and with the polygonal simulation model, you can simulate from multiple orientations, and you can see the result of the simulation for each of the setups in here. So you can see that the setup 1 and the setup 2, you can, get a feel for what is machined, what needs to be, what areas need to be refinished. And here you can see that I have some areas that needs to be remachined over here. So I have a horizontal finishing toolpath added in here that'll go ahead and clean up those areas.
One quick note here, they briefly touched upon it, as the work 0 operation that you see. For some people who might not be familiar with that, that's really a coordinate system shift, which is either a G54 or a G55 on your machine. So that allows you to move the coordinate system wherever you want. Just want to make that clear.
Thank you, Joe. So now we talked about how we can create setups where we have to manually flip the part and then establish the origin for each orientation. Now if you had a 4-axis machine tool and you wanted to use indexed programming, rather than having to do a coordinate system setup in here, we'll be using a rotate table setup. Now what I'm going to do here is modify some of the operations on this particular toolpath to demonstrate that. So first thing I'm going to do is change my machine type from 3 to 4-axis, and I'm going to pick the configuration as table, where the part would be rotated on a rotary axis or a rotary table, and I'm going to set the rotational axis to be about the x-axis, and I'll go ahead and select OK to accept it. And in the next step, what I'm going to do is establish my origin right over here. So rather than having to create a work 0 to shift or translate the origin, I'm going to remove this work 0, and I'm going to go ahead and do an align, set world coordinates, set to stock, high Z southwest. I'm going to shift the origin right in here. So that'll eliminate the need to add an additional work 0. And then I'm also going to make sure that I go ahead and set my rotation center to be the center of this block in here. So I can establish a center point. There's a couple of ways you could do it. If you want to quickly do it in here, I can basically establish the intersection of these 2 points in here. In the CAD system in Rhino, I can use that. So I can basically go ahead and pick the intersection of these 2 right here. And I'm going to use the intersection snap, and I go back to the machine setup, and I want to put my rotation center right over here at the intersection of these 2. So that's going to be my rotation center in here. So when you're defining and programming this as an index 4-axis, You do not have to go back and re-zero it on the machine for each and every setup. That's the beauty of it. You just establish the origin and the 0, 0, 0 for the first orientations, and everything else will be automatically handled. So in this particular case, I'm just regenerating the operations for setup number 1. So we have these machining operations programmed in here, the roughing, the drilling, and the finishing operations. Now for the setup number 2, I would need to create what is called a rotate table setup and not a coordinate system setup. So I'm going to select setup and insert what is called a rotate table setup. And now I'm going to specify the table rotation angle, and I'm going to flip this over by 180 degrees. And you will notice that based on the coordinate system origin and the rotation center, the origin for the rotate table setup is automatically established. So when you select OK in here, you will see that it automatically creates the origin, so you don't have to go back and re-zero it on your machine tool, and it's right exactly at this location. So what I'm going to do is take these 3 operations I had, place it under the rotate table setup, and then regenerate these operations. So this is how you can program if you have a 4-axis machine tool and you want to program an indexed operation. So you have your default setup, and then you can create additional rotate table setups in here to establish the rotation along the defined rotational axis of your machine tool. So we now have the roughing, finishing, and the final finishing operations for each of these orientations. Folks, if you have any questions about setups or rotate table setups, please feel free to post those questions in your questions panel, and we'll try to get them answered for you. Now let's talk about how we can establish orientations in Visual Cam for SOLIDWORKS and in Alibre Cam. So first I'm going to take an example in SOLIDWORKS. Now as you can see, the way it's modeled in SOLIDWORKS, typically users are taught to use a reference based off the top plane when you model a part in SOLIDWORKS. So when you go into the top plane, you're noticing that this is your X and Z axis. So typically when you model a part in SOLIDWORKS, you'll be starting out from the top plane, and you'll notice that the coordinate system that you see here is automatically coincident with the coordinate system that you have in the world coordinate system of your host CAD system, which is in this case happens to be SOLIDWORKS. Now in Visual Cam and RhinoCam, we had to rotate the part or reorient the part to establish the origin for machining. So in this particular example, we would like to mill looking down from that face, but this happens to be, this face, the Z is not normal to this face the way the part has been designed. So what we would need to do is we need to reorient the coordinate system. So rather than having to go back and redraw the part or redefine the part by changing the sketch planes, there's a very easy way to handle this. So you go into your machine tool setup dialog on the program tab, and you'll now notice that there's an additional tab that shows up in Visual Cam for SOLIDWORKS as well as in Alibre Cam, and this would allow you to orient the coordinate system from the direction you would like to machine the part. So in this particular case, I want my Z-axis to be normal to this face, which means I want a machine looking down to this particular plane in here. So rather than having to go back and reorient the part or recreate the part, you can use these controls. This could be using either the spin angle, or you can use select the surface. You could pick a face in here, and you'll now notice that the Z-axis is oriented normal to this face. So you establish the Z-axis normal to this face, and I'm going to toggle off the display of the world coordinate system, so you can now notice that the machining coordinate system is oriented from the orientation of the world coordinate system. So in the world coordinate system, the Z-axis is normal to this particular face, but we now change the machining coordinate system to be normal to the top face right in here. Now, if you need to reorient your X and Y, you can go back to the machine tool coordinate system, and now I can rotate it so that my X-axis is parallel to the longer edge of the part, and the Y-axis is along the shorter edge, so you can re-establish that. So once you establish the machine tool coordinate system, you can then define your machine type, whether you're going to be programming this as a 3-axis, or you want to do it as an index 4-axis, or as a 3+2 with a 5-axis machine tool, so the workflow would remain the same. So we've established the orientation, and then we can define our stock. So as you define your stock geometry, you will notice that the stock extents that you see here are based off the machine tool coordinate system orientation. So the length of the stock is 10.5 inches on the machine tool coordinate system of the x-axis that you defined. The width and the height or the thickness is 1 inch. So once you've established the coordinate system orientation, you would go through the process of defining your stock. You could then establish your work 0 to shift or translate your coordinate system origin. And this could be, your work offset could be a G54, a G55, or 56, or whatever the coordinate offset is for your machine tool, and then you would program your machining operations. So this is a similar workflow both in Visual CAM for SOLIDWORKS as well as in Alibre CAM. Now, if you do not have the option to create multiple setups in here, which is available in Pro and Premium configurations, you would actually have to create multiple parts, save copies of the part, and then you'd have to go back and change the machine tool coordinate system origin to program the part from additional sites. So you can rotate the coordinate system, and your default setup will automatically inherit the coordinate system orientation that you established under the machine tool coordinate system tab. Folks, again, if you do have any questions about orienting the coordinate system in Visual CAM for SOLIDWORKS or Alibre CAM, please feel free to post those questions and we'll try to get them answered for you.
Uday, there's a question from one of the attendees, which I am stumped actually. This is the question about if they purchase the 3+2 module, would they get the automatic feature detection and automatic feature machining from multiple orientations? I'm not sure about that, so I don't know if you know.
I would have to verify that and get back to them, Joe.
Okay, yeah, that's what I told them as well. So, all right, thank you.
Okay, thank you. So let's take a look at an example on how we can program, index 5 axis for parts that are non-prismatic. For example, if you have a part that's more of an organic shape, like you could be working with like scan models and stuff like that. So the workflow would be very similar. So you establish your machine tool. So in this case, I'm going to define this as a 5-axis machine tool using a configuration as head-head. And you can define your primary axis, your secondary axis. And then when you're working with a 5-axis machine setup, and if the configurations involves a head, you have an additional parameter which is a gauge length, which you need to account for or compensate for. The gauge length is typically in the distance, defined as a distance from the pivot point to the tool tip, and that needs to be compensated for when you're machining from different orientations as the tool is basically oriented in different directions in here. So the gauge length, this information is something you can find out from your machine tool. The gauge length, the distance from the pivot point to the spindle face or the collet face would be a fixed parameter for a given machine tool, and this is something you can obtain from your machine tool manual, where you can determine what this is, or you can talk to your machine tool vendor and they can provide that information to you, and that is something that you can input it in here. And this is typically the case when you're working with any configuration that has a combination of a head, which could be a head-head or a table head. The gauge length wouldn't apply if you have a table-table configuration on a 5-axis machine tool. So in this particular case, we've defined the number of axes to be 5. The configuration is head-head. We've defined the primary axis. Typically on a head-head configuration, the primary would be a z-axis, and then we have a secondary axis. So the workflow of creating the tool paths is very similar to what we noticed for 3+2 machining. So you program toolpath for each of these orientations. So the default orientation here is looking down from the top in here. So we now have a roughing toolpath that's programmed. And then we have additional orientations we've created. So we want to machine from the front and the back. So we have a re-roughing operation program from the front side. We have a roughing operation program from the back side. And we can create additional finishing operations from each of these orientations in here. So this is how you can program from different orientations by creating multiple setups or coordinate system setups, where you can lock the coordinate system to any given plane, and then you can program 3-axis toolpaths. Now once you have these operations programmed, you could go ahead and, if it's a 5-axis machine tool, you can just select the post processor that is appropriate for your machine tool in here. And then selecting post will automatically post all of these operations in here, or you can just select a set of setups in here to post it. I can select setups 1 through 5 and right click and do a post. And I'm going to call this give it a name for the file, and post it out. So you'll notice that once the code is posted, it automatically computes and outputs the rotation, the angles for each of the orientations in here. So I'm going to do a search for setup number 2. You'll notice that the B turns 90 degrees. You'll notice that the B goes 270. So you can specify, also you can control the rotational axis limits for your machine tool depending on if the machine tool has a limit for the primary and the secondary axis. These can be set right in here for the primary and the secondary axis. And I'm going to go ahead and apply a limit in here. For the secondary, I'll put in plus to minus 90 degrees. When I repost this out, you will notice that the rotary axis limits are automatically being honored when the angles are computed in here. So in this particular case, we have B0, C0 for the first one. You'll notice that for the next orientation, you have a B270, C90, which is the secondary is 90 degrees. You have a B90, C90 for the back face. So it automatically computes angles for each of the orientations. So all you have to do is establish the origin, and each of the setups can be programmed, and the system will automatically compute the angles and output along with the coordinates for you. So this is one of the ways how you can program 3+2 machining or index 5-axis machining if you have a 5-axis machine tool. So if you're working with a 3-axis machine tool, then you would have to reorient the part for each of these orientations and then post each of the setups out to your machine tool as a separate file. Folks, if you have any questions at this point of time, please feel free to post those questions in your questions panel, and we'll try to do our best to get them answered for you. So the next thing I would like to cover here is how we can orient the part when we take a part from an assembly or a sub-assembly in here. To demonstrate this, I'm going to go back into RhinoCam again, and I'll take a look at an assembly example in here. And let's consider that the part we have in here, so there are several different components in this assembly, and let's say we want to grab one of these parts for programming in here. So I'm just going to go ahead and select this, and then I'm going to invert or hide all the other parts in here, or get rid of the other parts. So we have this component in here, we want to machine it. So once you have the part defined that you want to machine, you want to orient it. So go through the similar steps like we did earlier. Go to the Setup tab, orient the part. You can pick a face, or you can choose the direction that you want to orient it from. So you oriented the part. You establish your origin in here. And now you can start defining your stock material and start generating your toolpaths. So the workflow is very similar. So you have a setup 1 for programming features looking down from the top. Now you can add additional setups in here for machining from additional orientations to drill the holes over here. I can add an additional setup in here to machine it from the bottom face. So just rotate the coordinate system, and you can establish the origin for each of these faces. Now I have this part completely programmed in here. I'm going to go ahead and load the part in here so you can see exactly how we programmed it. So we have the pocketing operation for the top face. So I did a whole pocketing and a whole profiling to program it from the top. And this is all being programmed on a 3-axis setup. You would then reorient the part to program it from the bottom side. So you would basically be flipping the part over. As pointed out earlier, the benefit with the 3+2 module is you can program and simulate from multiple orientations within the same part, and you don't have to create multiple files. So it makes it easier for your file management, as well as being able to program and simulate from all the different orientations within one single file. So we have a roughing operation which clears this material out, a profile operation to finish the side, and then we have a drill operation to drill the holes. So we are drilling it halfway through from one side, and then we are going and drilling it in from the other side as well. And finally, we are doing a whole pocketing operation. So when posting it out as a 3-axis mode, so you can just select the setup, right-click and do a post, and you'll automatically be prompted with this dialog in here saying that the machine tool does not have sufficient access to post-process the selection. This is to let you know or warn you that, make sure that you've reoriented the part on your machine tool because you're programming it from a different orientation, so you need to make sure that the part has been reoriented correctly, and then you can select the post processor that's appropriate for your machine tool to post it out. So each of these setups can be posted out separately to separate NC files if this is being programmed as a 3-axis operation. Folks, again, if you do have any questions, please feel free to post those questions in your questions panel, and we'll try to get them answered for you. Now, the last thing I would like to cover today is the post-processor considerations and how we can configure the post-processor to output the primary and the secondary angles, and how this is done in our post-processor in here. To cover this, I'm going to basically use the same example that I have in here. And I'm going to go into the post-processor dialog in here, going to set post-processor options. And I'm going to pick one of the sample posts I have in here, and I'm going to pick edit. So this displays your post-processor generator. This is where you can configure the settings for your post for your machine tool. And for indexed machining, which could be 3+2 machining, or it could be rotate table setups, we have a section called setup in here in the post processor, and this is where we can configure the macros and the variables that we would like to output for each setup in here. So in this particular case, for a coordinate system setup, which is like a 3+2 machining, what I've established here is I've created 2 variables in here to first move the tool to a safe tool change point or tool change location. And this tool change location can be defined in your machine setup dialog in here, where you can specify a safe height. So I could say I would like to move the tool up in a Z maybe by 5 inches, and then maybe I can move it, back it up in X and Y, or leave it where it is. I can move it to the tool to a safe location in the Z and the X and Y, and then I can perform the rotation in here. So you can either output the secondary axis and the secondary angle first and then do the primary, or you can do the other way around. So depending on what your machine tool prefers, whether you want the primary axis and the angle to be output first and the secondary, or the other way around, and then you can have it move to the pre-position to the next location. So if your machine tool that you're using has a trunnion, you typically want to move up in a Z and then move over in X and Y, as opposed to if you have a machine tool that has a head, you want to move it in X and Y and then in the Z. So you can reorder these two in the post processors. So depending on whether it's a head configuration machine or a table configuration machine. So you have the detailed control available here in the post processor to accomplish this. So this is where all the macros go in for the indexed operations. Now under the multi-axis motion tab, you can establish the axis code for your primary axis and the secondary axis. So if your primary axis is called the A axis, you can specify this as A. Your secondary could be a C axis or a B axis. You can specify this right in here. Now for programming 4-axis or index 4-axis operations, the setup macros are defined under setup 1, which is for the rotate table setups right in here. So this is where you would define the setups. So once you have this information saved, now let's go ahead and define the machine tool as 5-axis, and I'm going to specify the primary, the machine tool as a table, primary and the secondary axis right in here. And now when I post-process these tool paths, you will notice that it automatically outputs the move to a tool change point to a safe location as we specified in the machine tool setup right in here, and then performs a rotation and moves down in a Z and then in an X and Y. So when I go back and do a search for the next operation in here, you will notice that again, before the start of setup 2, the tool moves to a safe location and it computes the rotation angles for each of these setups in here. So that's how we can configure your post processor depending on what would you like to perform after the table rotation or rotation of the head, you want to move in X and Y or Z, so you can configure the post. And you can find a list of all the variables that are available to you in the post processor by going into any of these macro definition areas, and you can right mouse button click, and this will populate all the list of variables. And if you want to insert a variable, just place your cursor, select the variable, it'll automatically insert it into the post processor for you. And again, if you need any help modifying or tweaking your post, you're always welcome to reach out to us, and we'll be more than happy to help you out. Folks, if you do have any questions at this point of time, we'll be more than happy to take those questions and answer them for you.
There's some questions about the 3+2 modular, so there are actually quite a few questions on that. Since we do not have the 3+2 functionality in the standard configuration, people are asking about the 3+2 module and how much it costs. So let me take that question. Yeah, so the 3+2 module is a separate module that can be purchased. It's actually included if you already have the Pro or the Premium configuration. It's already included in that. You don't need an additional module. But we made it easier for people who have the standard, expert, or the express configuration to just add on the 3+2 module. The cost in North America is $500 US. In Europe, it's going to vary. Typically, it's 500 euros, and the rest of the world you have to check with the local resellers. So I hope that answers the question. Also, there was a question on simulation and the 4-axis. Do you see the part rotating or do you see the tool rotating?
Okay, that's a great question, folks. So typically when you perform just a cut material simulation, you'd always see the tool rotating. But if you perform a machine tool simulation, and that would be able to show the part rotating if it's a 4-axis machine tool. So you can create a machine tool simulation by going into the load from file option. So the machine tool simulation is available starting with our expert configuration. You can go to load from file and you can pick a machine tool from the list of machine tools that are already built in and included in here. And you can perform a machine tool simulation which would show the rotation of the part. If it's a 4-axis or if it's a 5-axis machine tool, it could be, if it's a head-head configuration, then it would show the tool being oriented to different faces as you're programming it. I hope that answers your question.
Okay, it looks like we're at the end of the AMS webinar. Thanks a lot for all of the active participation. We had quite a few questions. Like I mentioned before in the beginning of the webinar, we will be making this recording available, and we will be in touch with all of the registrants once the recording is ready. Thank you again, and hope to see you next time. Take care.